All right, welcome back to Drive-Through Confessionals, second semester edition. Special shout out to the Sycamore Deli. Hungry? Stop by the deli. Get yourself a sandwich. Here we are, Chapter 10 notes. We're getting you prepared for your Math Excel assignments. This chapter is all about area, one of the key concepts of geometry. So let's talk about just area in general. Area is used to find the amount of space, two-dimensional space of things that have boundaries. Think about like a guy that mows lawns. He's not going to charge the same amount to mow my little, poor little small yard as he would charge to mow the yard of some rich millionaire with a huge acreage. So they had to figure out how to measure size. So they're like, well, let's pick some units. So everything in area is measured in square units. So this thing right here might be a square mile, or a square inch, or a square centimeter. Okay? So that is 1 unit squared, or 1 square unit. Okay, so that's all they are. They're literally squares. And obviously, sometimes it's impossible to just count the squares. So if we were dealing with a circle, that's an unacceptable circle. There's not going to be all whole squares in there. If we divide this thing up into square units, it's not going to be a whole number, which is why, when you find the area of a circle, very rarely will it end up being, a non-terminating decimal. It involves pi. That's why that happens, because they're not whole squares. Whereas the area, of a rectangle is often just a whole number, because there's an equal amount of squares that go in it. So the first thing you need to know about area is that we are dealing with square units. Now, as we move forward into 3 dimensions, you got to know that, things that have 3 dimensions have volume, but they also have area. Think about it like your house is 3-dimensional, but you paint it, which is 2-dimensional. So things that have 3 dimensions have volume, but they also have area, and that's going to be called surface area, but we're not going to deal with that yet. If you can do area, surface area is a breeze. So the area of a rectangle is length times width. So this would be the length, and that would be the width. So, we won't do this every time, but this is how the cavemen figured out multiplication. They were like, well, how many squares are in this rectangle? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And they kept counting, and then some other smart caveman was like, no, we should do multiply. It's quicker. And then you do 7 times 4. Which is 28 square units. So instead of counting, we multiply. It's just quicker, okay? What about the area of a parallelogram? Well, surprisingly to some, it's the same formula. But instead of length times width, now we have to call it base times height. So we actually probably could use that same formula, B times H, for the area of a rectangle. The area of a parallelogram is base times height. Remember that the height has to be perpendicular to the base. But if you think about this, think about if I took this triangle here, right here, and I removed it, and I glued it on over here. Well, lo and behold, okay, the base hasn't changed, the height hasn't changed, and that is why these two things have the exact same area formulas. If I divided this shape, which is now a rectangle, into, it would be the same shape. So there you go. Both rectangle and parallelogram have an area that is base times height. All right, the area of a triangle, okay? Not a right triangle, not an isosceles triangle. What if it was just some general triangle? Well, the thing about triangles is if we have a triangle, we can always copy it over itself, and now we've just made, it doesn't matter what type of triangle we had, we just made a parallelogram. Well, we just found that the area of this parallelogram, since this is an obtuse triangle, notice the height is on the outside from this base, okay? The area of this entire shape surrounded by the blue lines, the area of the parallelogram is base times height. Well, that's not what this page says. We don't want a parallelogram. We want the area of a triangle. Well, then the area of this triangle, this red area, is half of that. So here you go, the area of the triangle, and I think you guys already knew this, but now maybe you understand why, is 1/2 base times height, because a triangle is half of a parallelogram. Okay? Moving along. The area of a rhombus. You might be thinking, well, why are we learning the area of a rhombus? Because a rhombus is simply a type of a parallelogram. But, so, I tell you this. You could find the area of a rhombus by doing base times height. Alright, now here's the bad news. Sometimes they don't give you the base and the height of a rhombus. Okay? And that's because they want you to use a different feature of the rhombus. If you remember that a rhombus has diagonals that perpendicularly bisect each other. That's an important fact. This is why you learn geometry in a certain order. So let me tell you that if you want to save space in your precious brains, you don't have to learn this formula, because you already just remembered the area of a triangle formula. And if we wanted to, like what I would honestly recommend to you guys is that you would just find the area of this triangle and then multiply it by 2. That's the best way to do it. But there is a formula for that, and the formula comes from what I just described. Whoops. So this length is D1, the length of the one diagonal. There you go. And let's use green. This length then is D2. Okay? So the area of a rhombus can also be found by doing 1/2 times the first diagonal times the second diagonal. Where did that come, you may ask? Well, let's look at in black here. Let's look at the area of the yellow triangle. Well, that area would be 1/2. Look, the base of the triangle is D1, and the height of the triangle is 1/2 of D2. So that would be the area of the yellow triangle, and we could simplify that to 1/4 D1 times D2. Well, if we wanted to find the area of the rhombus, we could simply take the yellow triangle and multiply it by 2, and that is how we come up with this formula. So like I said, if you're a memorizer, feel free, memorize this. If you are a thinker and a problem solver, just make sure you know how to find the area of a triangle, which I'm confident all of you do, and just work your way through the problem by finding the area of the triangle and multiplying by 2. If you really wanted, you could find the area of this black triangle and multiply by 4. It's all going to work. Just use your common sense and don't make mistakes with your math. All right, moving right along. Area of a trapezoid. Okay, so you've seen so far that all of these have involved base and height in some way, and this will too. Okay, here's the deal. If I use the bottom base, the bigger base, and I multiplied by the height, it would give me the area of this rectangle, that green rectangle. And that would clearly be too much area because we have some stuff here, some stuff here. So that would be too much. But if we use the smaller base and multiplied by the height, that would find the area of this red rectangle. And now that would be too little. We wouldn't account for this area and this area. So, you know, what do we do in math when one thing gives us too much and the other thing gives us not enough, and we want to know what's right in the middle? Well, we take the average, and that is the area formula for a trapezoid. You could write it like this: average base times height, or you could write it as 1/2 times B1 plus B2 times 8, keeping in mind that this thing right here is just the average. That's how you find the average in life. You add it and divide it, or you add it and you multiply it by a fraction, because that is what division is. All right, we're moving along fast. Feel free to rewind the video at any time, pause it to make sure you're taking the right notes. The area of a kite is next, okay? So, a kite can kind of be thought of similar to a rhombus because a kite has diagonals that are perpendicular to each other. The difference is only one of them is the perpendicular bisector of the other one. Okay, so I'll save you some time here. We won't go through it all. Remember the story about the yellow triangle? Well, look, this is the exact same situation. So we'd really like to find the area of that yellow triangle and multiply it by 2, and what that ends up being is area of a kite is 1/2 D1 D2. So it is the exact same formula as a rhombus. Okay? Area of a regular polygon. We'll start with a hexagon because that's the easiest to draw. Okay. You've got this Trivial Pursuit piece. I don't even know if you guys know what that game is anymore. All right? So a hexagon can be represented by 6 congruent triangles. So some smart person was like, well, why don't we just find the area of one triangle and multiply by 6? And that's exactly what we're going to do. We just got to know some words. So the height of one of these triangles, is called the apothem. Sounds like a cute rodent with a lisp. Okay? And then if you can think of, like, if this was a circle, notice the apothem would not touch the circle. And so this here thing is called the radius. Okay? Because it is the radius of the circle. You'll have to know that at some point. Okay? So the area of the triangle, and this would just be, we'll call it, let's say, S for a side of the hexagon. Okay? The area of the triangle is 1/2 S times A. Remember, A is the apothem. S is the side. So the area of the hexagon is 6 times 1/2 times S times A. Now, here's what I want you to know. 6 times S will be the perimeter. Okay, because all the sides are the same. Keep in mind, these are regular polygons. If it's not regular, then we probably can't find the area of it without using some trig, which you guys don't know yet. Okay, so by this train of thought, you're going to see this formula written as this: the area of a regular polygon is equal to 1/2 times the perimeter times the opossum. Okay? Is that right? Let's see. 1/2 base times height times 6. 6s is the perimeter. 1/2. Yep, that's right. You might be alarmed and be like, are you serious? Mr. Ulan doesn't really know this equation? And I don't. I swear. I just would always find the area of the triangle and multiply it by 6. So you could do is equal to the area of a triangle times the number of triangles. Alright, both those work. These are the same exact things. If you're a thinker, you might want to think about why are these the same things. I tried to give you some hints throughout here, but alright. One little aside, okay? So, a lot of times, let's say again we had a hexagon. And let's say we knew all they gave us was that the perimeter was 60. So we knew that each side was 10. We could actually find the area of this shape just based on that. But you have to know a little SOHCAHTOA, okay? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. You might have heard me say SOHCAHTOA. What the heck does that mean? SOHCAHTOA. It's a mnemonic device. Okay? Or, I guess it's an acronym. One of those two. Okay, so, in this problem, remember that all of these triangles are congruent, and that you could always imagine that there's a circle around this. Okay? So, since all of the triangles are congruent, this angle right here will be 360 divided by 6, which is 60 degrees. You know that these are radius. So this triangle right here is actually an equilateral triangle. Okay? So what we'll do to find the height of an equilateral triangle is we'll draw it. Okay? I know that this is 5 and 5 because it's an isosceles triangle. We want to find A, which is the opossum. The base angle is 60. The adjacent side to 60 is 5. We are looking for the opposite. We know the adjacent, so that tells us to use tangent. Okay, so we would say tangent of 60 is equal to A, which is our opposite. Stands for opossum, not adjacent. That gets confusing, and I'm sorry. Over adjacent, which is 5, okay? So to find the opossum, we would do 5 times the tangent of 60, and that's a calculator thing. Uh-oh, I cleaned up, and I don't know where my calculators are. Now, I can tell you that it's going to be 5 radical 3 over, 5 radical 3. But that's special right triangles, and you also don't know that yet. So I'll do 5 times tangent of 50. Sorry. And I get one. No. I'm in radians. Sorry. Awkward. Alright, you end up getting 8.66. So now the area of the hexagon is 1/2 times the base of the triangle times the opossum, Keep in mind, this is the area of the triangle. So then I got to do times 6, because there are 6 triangles in that hexagon that are equal to each other. And you end up getting 259.8. Finally, area of a circle is pi times radius squared. What is pi? Well, you guys know it is 3.14159. Keep in mind that this year, pi will, on March 14th, it will be 3/14/15. It's big. It's like one of the biggest days ever. Okay? So you know this. Why am I teaching you this? Because you may not know what a sector is. A sector is simply a slice of pizza. The radius and the central angle are the variables here. The bigger the angle, the bigger the slice of pizza. The longer the radius, the bigger the slice of pizza. So those are the two things that change the slice of pizza. If you can keep in mind that there are 360 degrees in a triangle, that right there then represents how much of the triangle we have cut. Okay? So think about it. If this is called a theta, don't freak out by new things, okay? Don't get freaked out. So the area of a sector, think about if this theta, this is theta, was 180 degrees. Well, that would be half of the circle. 180 over 360 is half of pi r squared. That's all we do. That's the area of a sector. The central angle, which is this, theta, over 360 times pi r squared. And finally, what if we wanted to do some special area problems like this? Let's say we were just find the area of the shaded region. All you got to do for these is have a plan. Everybody has a plan until they get punched in the mouth. Mike Tyson said that. It's one of my favorite quotes. All right, so let's say that this is a 10 by 10 square, and we want to find the shaded area. Well, now we know that our radius must be 5. So it's like we had a square and we cut a circle out of it. So the area of the shaded would be the area of the square minus the area of the circle. So it's 10 squared. That's why they call it squared. Oh, amazing. Minus pi times 5 squared. And you would best write this as an exact answer. 100 minus 25 pi. Alright, and that is your introduction into area. You will use this to help you succeed on your Math Excel assignment from Chapter 10. I wish you all the best of luck. Nothing but love. Boom!